All right, let's talk about one of the most powerful features in Cisco ACI, Layer 3 transit routing. We're going to break down how you can take your ACI fabric and turn it from just an endpoint into a really intelligent routing domain that connects all your different external networks. Honestly, this is a game changer for most ACI deployments, so let's get right into it.
So, here's our game plan. First, we're going to unpack ACI's default behavior as a stub network, and, why that's even a problem to begin with. Then, we'll dive into the solution, transit routing. We'll look at two different ways to set it up, the old-school default export profile and the more modern export control subnet method. After that, we'll see how to make this work at scale and touch on the super important role of contracts and which routing protocols play nice together.
All right, first things first, let's set the stage. We need to understand how ACI handles external routing right out of the box because, well, its default behavior creates a pretty big limitation that we need to solve.
By default, ACI acts as what's called a stub network. The easiest way to think about this is like a cul-de-sac. Traffic can go in and traffic can come out, but it can't go through it to get somewhere else. So ACI is great at telling the outside world about its own internal networks, but here's the kicker. It will absolutely not advertise a route it learns from one neighbor to another neighbor. It's a dead end.
This diagram just lays it all out perfectly. Over on the left, you've got a partner router, and it's sending its routes into the ACI fabric. The fabric learns them just fine, but then look at the right side. The fabric never passes that information along to the legacy router. That big red X says it all. Even if they're in the same VRF, those two external networks might as well be on different planets.
So how do we fix this? How do we turn our cul-de-sac into a superhighway? Well, the answer is a feature that completely changes the fabric's personality, turning it from a simple endpoint into a core part of your routing design.
And that solution is transit routing. This isn't some brand new feature either. It's been around since way back in APIC release 1.1. It lets the fabric do the one thing it couldn't do before, advertise routes it learns from one L3 out to another L3 out. It basically unlocks its potential to be a true transit network.
Okay, let's look at our diagram again, but this time with transit routing enabled. See the difference? It's huge. The fabric still learns the routes from the partner router on the left, but now that information flows right through the fabric. The export is active, and the routes get advertised out to the legacy router on the right. Just like that, we have a complete path for end-to-end communication.
Now, making this work is a two-step process. Step one is what we've been talking about. You have to export the routes. You have to tell ACI what prefixes to advertise and where to send them. But, and this is classic ACI, just having a route doesn't mean traffic can flow. Everything is denied by default. That brings us to step two. You must apply a contract between the two L3 out EPGs to actually permit the traffic.
Okay, let's get into the configuration. We're going to look at two ways to do this. And this first one, the default export profile, is going to feel really familiar if you've got a background in traditional networking. It's basically ACI's version of a route map.
So let's break down what's on the screen here. The most important thing is you have to create a route control profile with the exact name default-export. No other name will work. Then, you set its type to match routing policy only, and inside that profile, that's where you define a prefix list with the specific subnets you want to advertise. You can see here we're exporting a /30 and even a specific /32 host route.
Let's just hammer home the rules for this method because they are super important. First, the name has to be exactly default export. Second, the type must be match routing policy only. The cool part is, once you do this, ACI just automatically applies it. But here's a huge gotcha that trips everyone up. When you use this method, the subnets you define under the EPG itself, they should not be marked for export. Their only job is to classify traffic for your contracts. That's it.
Now for method number two, if that last one felt like you were writing a route map on a CLI, this next approach is much more, well, it's more ACI. It's simpler, it's more direct, and it's all about declaring your intent. With this method, you can just forget about creating a separate route profile. Instead, you go straight to the subnets defined under your external EPG. And for every single subnet you want to advertise, you just check the little box that says Export Route Control Subnet. That's it. It keeps your routing policy and your security policy all tied together in one spot. It's so much cleaner.
And honestly, this quote from the source material just nails it. It says, this configuration is simple and designed to reflect your intent directly, without having to mess with traditional route maps. That's really the whole philosophy behind this second method.
This slide right here is where it all clicks. For this to be a two-way conversation, the setup has to be symmetrical.
You see the top L3 out? It's exporting its routes down. And the bottom L3 out? It's exporting its routes up. You need that route exchange happening in both directions. And then, tying it all together right in the middle, you see the contract. That's the final piece of the puzzle that gives the traffic permission to actually flow.
Okay, so defining subnets one by one is fine when you've only got a few. But what happens in a big enterprise network with hundreds, maybe even thousands of routes? That's just not going to scale. So let's see how ACI handles that.
The solution is to use an aggregate option. Instead of listing every single subnet, you can use the default route, 0.0.0.0/0, to create a catch-all policy. Now, this is really important. This does not mean ACI advertises a default route out to its neighbors. All it means is that any transit route learned by the fabric will automatically match this policy and get marked for export. It's a match-all rule. And here's a look at how you'd set this up in both methods we talked about. On the left, using our default export profile, you can see we just add 0.0.0.0/0 as a prefix and check the aggregate box. Easy. On the right, with the subnet scope method, we define that same 0.0.0.0/0 subnet and check two boxes: export route control subnet and aggregate export. The end result is exactly the same, just a couple of different clicks to get there.
But this brings us to a really important trade-off. The default export profile, the route map method, is way more flexible. You can use that aggregate option with any summary route, like say 172.16.0.0/16, to just export routes from within that block. The export control subnet method, on the other hand, is more rigid. That aggregate checkbox only works with 0.0.0.0/0. That's a huge difference to keep in mind when you're designing your network.
All right, let's wrap this up with a few final but absolutely crucial details on how all this works with different types of routes and protocols. So what if the route you need to get from one side to the other isn't learned from BGP or OSPF? What if it's just a static route you typed in? No problem at all. The export logic we've talked about doesn't care about the protocol. As you can see here, you can define a static route on one L3 out and use the exact same export methods to advertise it right out another L3 out. Now, everything we've talked about for exporting routes has a twin: import control. You can use the exact same logic, a default import profile, or the import route control subnet scope to filter which routes ACI even bothers to learn in the first place. But there is a massive gotcha here. By default, this is turned off. To use any kind of import filtering, you have to go to the L3 out itself and explicitly check the box for import route control enforcement. This matrix, you're probably going to want to bookmark this or take a screenshot. This is your cheat sheet for which routing protocols can talk to each other through the ACI fabric. It's super useful. For instance, you can see it's perfectly fine to connect an OSPF domain to an eBGP domain. But notice those X's. You can't use ACI for transit between two iBGP peers, for example. Always check this chart when you're planning your design.
So there you have it. We've seen how to turn ACI from a simple stub network into a powerful transit core. And you've got two main tools in your toolbox: the super flexible route map style of the default export profile and the simple, clean, intent-based export control subnet scope. So the real question for you to take away is which one of these best fits your network and your operational style. Thanks for watching.